So we have discussed the discrete series. So same thing, it is an arithmetic mean for group data, but here we are going to talk about a continuous series. So class intervals are given here when we talk about continuous series. So the process of calculating this arithmetic mean when it comes to continuous series is same with that of the discrete series, but the only difference is that the midpoints of various class intervals are taken when it comes to continuous series. But for discrete series we did not take any class intervals midpoint, but for continuous series we take the midpoints of each of the class intervals, and class intervals are given when it comes to continuous series. So class intervals would mean this 0 to 10, 10 to 20, all these are class intervals. And there are different types of class intervals. So there are exclusive class intervals, that is example like 0 to 10, 10 to 9. So this is exclusive. When it comes to inclusive, examples are like 0 to 9, 10 to 20, and unequal class intervals like 0 to 20, 20 to 50. So these intervals is not same, that is why they are called unequal class intervals. So we have already discussed that there is class intervals, they might be exclusive or inclusive, or they are of unequal size. And we have just discussed the example of inclusive, exclusive, and unequal class intervals. So here we are going to discuss the direct method and also the step deviation method. So we are not going to discuss the assume mean method for continuous series. We have just direct method and also the step deviation method. So we have to calculate average marks of the following students using the direct method and the step deviation method. So marks are given here, 0 to 10, 10 to 20, 20 to 30, and etc. And number of students are like 5, 12, 15, 25, 8, 3, 2 respectively according to these marks, these class intervals. So computation of average marks for exclusive class intervals by direct method. So here it is an exclusive class interval, but inclusive is like this, like 0 to 9, 10 to 20, like this. But this is exclusive class intervals through direct method. So form a table like this. So marks is given here x, and the number of students, that is frequency. Number of students would mean from mark there are 5 students who scored between 0 to 10. There are 12 students who scored between 10 to 20. So that is frequency. And here, as I have mentioned, we have to take the mid value here. So mid value of 0 to 10 is 5. Mid value means the middle, the mean, we can say the middle point, the middle number. So midpoint of 10 to 20 is 15. 30, 40 midpoint is 35, and 50, 60 it is 55, and 60 to 70 midpoint is 65. So first find out FM. So you have to multiply these two, and we have this summation FM. So after obtaining this FM, you sum up all this FM, and what we got is 2110, because in the formula we have summation FM. And how do you find out D dash? Very similar with the ungrouped data that we have discussed, even for discrete series also. D dash, find out D dash, midpoint minus 35 divided by 10. 10 is the common factor. So by doing the calculation we get this, the values. And why do we find out D dash is we have to find out F D dash. F into D dash. So F is this one, and multiply F with this D dash. So 5 3s are 15 minus 15. That is how we get this summation F D dash, that is minus 34. So what are the steps that is involved here? So obtain the mid values. We have obtained these mid values denoted by m. Second step is obtain summation fm. So we have obtained this summation fm, and then apply the method directly. So the formula is this one. So summation fm is 2110. Summation f is how much? 70. So 30.14 marks is the mean average marks for all the students given here. So that is how we find out the average marks for exclusive classes intervals by direct method for continuous series under group data. So these are all arithmetic mean method. What we are left with is the step deviation method. So there are two steps that is involved for step deviation method. So first find out d dash, and d dash is found out by this method, m minus a by common factor. So c means common factor. So this is the first part. You have to find out this d dash, and we have found out the value of d dash and summation of this d dash. That is minus, I think. Yeah. So we have found out d dash, and since we have already found out d dash, it is easy to find out f d dash, because here it is summation f d dash, and we have found out that summation f d dash is minus 34. And what is summation f? Summation f is 70. So directly apply the formula here, and c is the common factor, and a is 35. So this can be any arbitrary number, any arbitrary figure, 35. So a means assumed mean. So we are assuming 35 is our assumed mean. So we can take any arbitrary figure from the given question. So we are taking here as 35a. So directly apply the formula, substitute the values, and we get 30.14 marks. So the answer is the same with the step deviation method and the direct method. So that is how we calculate continuous series. For continuous series, we use direct method and step deviation method to find out the average marks of a students that is given here. So there are two interesting properties of arithmetic mean. So note this point. Number one property is that the sum of deviation of items above arithmetic mean is always equal to 0. So symbolically, it can be given here two interesting properties of arithmetic mean. So it is said that the sum of deviations of items above arithmetic mean is always equal to 0. So symbolically, we can represent like this: summation x minus x bar equals to 0. So this is the first important property of arithmetic mean, which indicate that the sum of deviations of items of arithmetic mean is always equal to 0. So the sum of deviations of the arithmetic mean, so this is the arithmetic mean, deviation is this one, is always equal to 0. This is one important property of arithmetic mean. Second, arithmetic mean is affected by extreme values. So it is very important here that arithmetic mean is affected by extreme values. So any large value on either end, that is beginning or at the end, can push it up or down. So the value of arithmetic mean is affected by the extreme values, either at the end or at the beginning. So any large value can push up or push down the arithmetic mean value. There is two important properties of arithmetic mean. So weighted arithmetic mean. Why this topic comes under arithmetic mean? Because sometimes it is important to assign weightage to various items, according to their importance, how important these items are. If you want to make it out, you have to give a weightage to that items to calculate arithmetic mean. So for example, there are two commodities, mangoes and potatoes. So what happened is you are interested in finding the average price of mangoes and potatoes. So let us say the average price of mangoes is P1 and average price of potatoes is P2. So the arithmetic mean will be given by, P1 plus P2 divided by 2. So here you are not giving any weightage here, no difference. However, that is why if you want to give more importance to the rise in price of potatoes, that is P2. So if you want to give more importance to the rise in the price of potatoes, that is indicated by P2, to do this, you may have to use weights. Weight, W-E-I-G-H-T-H, weightage. You may have to use weightage to give more importance to particular item. The share of the mangoes in the budget for consumer, like W1. So weightage W1. So you are indicating or you are separating each and every item by giving weightage. If you want to focus on the price of potatoes P2, you are giving weightage to both the items, to all the items. So W1 is for P1 and W2 is for P2. So W2 is the price for potatoes. Suppose you want to find out the rise in the price of potatoes, you are giving different weightage. And now the arithmetic mean weighted by the shares in the budget would be, so now it will be different. The arithmetic mean W1 P1 plus W2 P2 divided by W1 plus W2. So now it is a whole lot of whole different story, because you have given a weightage to the items. So that is all about weighted arithmetic mean. And in general, you can write like this. So in general, the formula for weighted arithmetic mean is, W1 x1 plus W2 x2 plus divided by W1 W2 plus xn. So it will be equal to summation of Wx divided by summation of W. So this is the formula in general when we give the weighted arithmetic mean. So W1 x1 plus W2 x2 plus n number of W and x, and then it will be divided by the W1 plus W2 plus Wn. So it is coming like the summation of Wx by summation of W. So that is weighted arithmetic mean. With that, we have come to the end of arithmetic mean discussion. Next class, we will discuss about median and mode.